Right, this video will be about solving a projectile motion problem. It's specifically looking at a projectile motion problem where the projectile has some initial vertical velocity as well as the initial horizontal velocity that all projectiles have. So let's get started. Let's say that we have an archer that shoots an arrow from a bow. Okay, we'll just draw our arrow here. And this arrow is going to go up and come back down, right? So the arrow is shot at an angle of 30 degrees above the horizontal. Okay, 30 degrees above the horizontal, and it has an initial velocity of 45 meters per second. Okay, 45 meters per second. So the question that we are asked is to calculate the projectile's displacement in both the x and y directions after a certain amount of time, and the time that it wants us to calculate for is after 3 seconds. So we'll go ahead and write at 3 seconds. We want to know what the delta x and the delta y are equal to. So before we get started with that, are there any other things in this problem that we know? Well, in a moment what we'll want to do is break this initial velocity into its x and y components. So we know that we need to do that. Also, this is a projectile though, and in every projectile problem, at least problems on Earth, we are dealing with an acceleration due to gravity of negative 9.8 meters per second squared. So we'll go ahead and write that. We know that that's the case. Alright, so like I mentioned, our first step is to break this initial velocity into its x and y components. And so what we'll do right here is we have this total velocity of 45 meters per second, and it has some y component up and some x component to the side. Again, this is just breaking a vector down into its components. We're given that this angle is 30 degrees, so this is our adjacent side. So our formula for this is that the cosine of 30 degrees times our total velocity of 45 meters per second will give us our VIX, our initial horizontal velocity. And in just a moment we'll throw that in the calculator. Let's go ahead and do that actually. So we have cosine of 30 times 45 gives us 38.97. We'll call it 39. I'll just round that up. 39.0 meters per second. And we want to know our vertical velocity, which is the sine of 30 degrees times 45, our initial total velocity, meters per second, will give us, just come back in and edit this, cosine, or not cosine, sine of 30 times 45 gives us, well, if I approximate, 22.5 meters per second. Okay. So now we have our initial vertical velocity and our initial horizontal velocity, and we know from what we've learned about projectiles that this will be constant. There's no horizontal acceleration. So this will be our horizontal velocity throughout the entire problem. So now let's go ahead and get into our question. Our question asks us to find our delta x and our delta y for a given time. We know what that time is. We know what our vertical and horizontal velocities are. We'll look at the delta x first, and we'll choose a formula. Our formula that we will need is that delta x, our displacement in the horizontal direction, is equal to our Vx times our time. That's it. That's all there is to it. So we know that our our horizontal velocity is equal to 39 meters per second, and our time is 3 seconds. We were given that, right? So if we multiply those together, we see that our delta x is equal to 39 times 3, which is 117. And what are our units going to be? Our seconds will cancel, so that'll be meters. And that makes sense. Our delta x should be in meters. Our displacement should be in meters. That's the easy one. Delta y is a little bit trickier because our change in our y position, our vertical displacement, there's some acceleration, some vertical acceleration that we have to take into account. So the formula for this is going to be a little bit nastier. Delta y is equal to VIY times t plus gt squared over 2. Okay? We know what our initial vertical velocity is. We know what time is. We know what our acceleration due to gravity is. And we know what time is again. We're good. We're good. We have everything that we need to know to solve this formula. So let's go ahead and plug some numbers in. Delta y is equal to VIY 22.5 meters per second. I'm not going to have room. Let's come down over here. Delta y is equal to our VIY 22.5 meters per second times our time, which is 3 seconds, plus our g, negative 9.8 meters per second squared, times our time of 3 seconds, square our 3 seconds, square our time, divided by 2. Let's do this term first. 22.5 times 3. 22.5 times 3 gives us 67.5, and that'll be meters. Our seconds will cancel out, so we'll have 67.5 meters. Now, interestingly enough, that is how far this projectile would have gone vertically in 3 seconds were there no acceleration, were gravity not pulling down on it. The second term is gravity's effect on the projectile. Let's go ahead and do that. We have our 3 squared, which is 9 seconds squared. Okay, we'll multiply that by negative 9.8 meters per second squared. Let's go ahead and do that. Negative 9.8 times 9 gives us negative 88.2, and then we need to divide that by 2 to get negative 44.1, and we'll wind up with meters there. Our seconds squared cancel out, and we're left with just meters. So now we just need to add these two up. So 67.5 minus 44.1, we can go ahead and do that. 67.5 right here, minus our 44.1, and that is 23.4 meters. is our delta y? .4 meters. Good. Good. So that's our delta y. We have answered our first question, which is what is our delta y and what is our delta x? We'll box those in. The second thing that this problem would like for us to answer is what will be the projectile's x and y velocities after 3 seconds. Well, we already know that our x velocity, our Vx, is constant, isn't it? There's no horizontal acceleration. So we can go ahead and write for part B, we'll call this part A. For part B, Vx is equal to what it was up here, 39.0 meters per second. Right. Now our question is, what is our Vy? Well, to find our final velocity, it's a pretty simple formula. Final velocity is equal to our initial velocity plus acceleration times time. Do we know what our initial y velocity is? Yeah, it's 22.5. Do we know what our acceleration is? Negative 9.8 meters per second squared, right up here. And do we know what our time is? We're looking at it after 3 seconds. So we can go ahead and plug all of that into our formula. We have our initial vertical velocity of 22.5 meters per second plus a negative 9.8 meters per second squared times our time of 3 seconds. And so let's do this multiplication over here first. Negative 9.8 times 3 is equal to 29.4, and that's a negative number. It's 29.4 meters per second because our seconds squared and seconds cancel. Plus our 22.5. We'll carry that on down. And then that we'll do that addition. Add negative 29.4 to 22.5. And we wind up with negative 6.9 meters per second is our final velocity in the y direction. So that is a velocity down. That means that our projectile has already hit the high point in its path after 3 seconds and is starting to come back down. It has some negative y velocity. Well, that's it for this one. I hope that this has been educational and that you've seen a little bit more clearly how to solve some of these projectile motion problems. Be sure to check out my projectile motion video on how to solve a problem where the projectile has no vertical velocity. It's all in the horizontal direction at the beginning. So be sure to give that a look. Thanks.